Welcome to a deep dive into databases.
Ooh, sound exciting.
You've given us a really interesting mix of sources, textbooks, articles about how they're used.
Sounds like someone wants to really understand databases.
Not just how they work, how they're changing too.
Right, right.
So we're going to cover the basics of relational databases. Then we'll look at NoSQL.
And maybe even some of those more advanced things you sent about.
Yeah, absolutely.
It's kind of wild how much we rely on databases every day.
I know, right?
Most people don't even realize it.
Yep.
They're everywhere.
It's like there's this hidden world that makes everything work.
Online shopping, social media.
All that stuff, yeah.
Even scientific research, financial markets.
Oh, one of the articles you sent talked about that.
Oh, yeah.
How stores use databases to, personalize your shopping experience.
Yeah, they can even predict what you might want to buy next.
It's kind of freaky, actually.
It is, but it just shows how powerful data analysis is.
Yeah.
Databases aren't just for storage anymore.
Right.
They're becoming these tools for making decisions.
Yeah, it's pretty amazing.
But before we get too deep into that...
We got to start at the beginning.
Exactly. You can't have a database without data itself.
So, what exactly is data?
Right. Why is it so important?
I never really thought about it until I started reading this stuff.
Yeah.
We use that word all the time.
Data, data, data.
But when you actually stop to think about it,
What does it even mean?
it's actually a pretty big concept.
It is. It's any collection of facts, figures, or observations, really.
So it can be structured, right?
Yeah, like all those rows and columns in a spreadsheet.
Super organized.
Right.
But it can also be unstructured.
Yeah, think of like a bunch of text messages.
Or social media posts, that kind of thing.
Exactly, and it can be about numbers and measurements.
Quantitative stuff.
Right. Or it can be about descriptions or opinions, more qualitative.
Interesting.
And the sources you sent seem really interested in how different kinds of data are managed.
Yeah, one of the articles was all about sensor data from those IoT devices.
Oh, right, those smart devices.
Yeah, exactly. And another one talked about how they analyze customer reviews.
Oh, so they can understand how people feel about a product.
That's it, yeah.
It's fascinating how the way we manage data really depends on what kind of data it is.
Makes sense.
And what we're trying to do with it, and that's where databases come in.
Right, they give you that structure.
Yeah, the tools you need to store, manage, and analyze different types of data.
It seems like those early databases, like the hierarchical and network ones.
Yeah, those were pretty rigid.
And complicated, too.
Like a tangled web, hard to work with.
I can imagine. It'd be a nightmare to manage all the data we have today using those old systems.
Oh, for sure. So that brings us to relational databases.
Right, the big revolution.
That changed everything.
Relational databases.
Or RDBMS, as you might see it written.
Yeah, I've seen that.
They're a much simpler way to organize and manage data.
So it's all about tables, rows, and columns.
Exactly, like a well-organized spreadsheet for each type of data you want to keep track of.
So, if I'm building a database for an online store,
Okay, yeah.
I'd have a table for customers, one for products, and one for orders.
Exactly. And each table would have columns for all the important details.
Like the customers table would have columns for their name, email, address.
And the products table would have columns for the product name, description, price.
And the orders table would link those two together, right?
Exactly. That's where those keys come in. Primary keys, foreign keys, all that.
I saw those terms in the textbook, but honestly, I got a little lost.
Yeah, it can be a bit confusing at first.
Can you break it down for me?
Sure. Keys are basically unique IDs. They connect the tables together.
So each customer would have a unique customer ID.
Right, and that would be the primary key in the customers table.
And then that same ID would show up in the orders table.
Exactly. That way, you can see which customer placed each order.
Oh, okay. So it's like each customer have their own little ID card.
Yeah, that's a good way to think about it.
And that card links them to their orders, which are then linked to the products.
Exactly, and that's the power of relational databases.
So what's the big advantage of doing it this way?
Well, it ensures data integrity, consistency, and flexibility.
What's that mean exactly?
Though, by defining relationships and rules, you keep the data accurate and meaningful.
Okay.
Like, you wouldn't want to accidentally delete a customer who still has active orders in the system, right?
No, definitely not.
So a foreign key constraint would prevent that from happening.
So it keeps everything in sync and prevents accidents?
Exactly. But even with all these advantages...
Relational databases aren't perfect.
Right. One article you sent talked about how they struggle with huge amounts of unstructured data.
Like, think of all the posts on social media.
Right, or all the data from sensors.
That's where NoSQL comes in, right?
You got it. NoSQL, or not only SQL, is designed for these massive unstructured data sets.
It's more flexible.
And more scalable, too. Better for certain types of data.
This is where it gets really interesting for me.
Yeah, me too.
I was hoping we could dig into NoSQL in the next part.
Oh, absolutely. We've got plenty to talk about.
I'm especially curious about the different types of NoSQL databases
Yeah, there are quite a few.
and how they're being used?
Right. We can definitely get into all that.
Awesome.
You've sent some great sources on that, so we can really tailor the discussion to your interests.
Okay, so NoSQL.
Let's do it.
It seems like a lot of those articles you sent are talking about this.
Yeah, it's pretty popular these days.
Like, one talked about social media platforms
Oh, yeah.
using NoSQL to manage all the user profiles.
Tons of data there.
And another one talked about scientific research.
Using NoSQL for that, too.
Yeah, storing and analyzing all that genomic data.
Wow, that's amazing. It really shows how NoSQL is perfect for these huge applications.
Right, they're designed to handle all that data.
So much data these days.
So many users, too.
Yeah. NoSQL can adapt and grow with it all.
So let's talk about the different types of NoSQL databases.
Okay, yeah, good idea.
That textbook excerpt I sent mentions a bunch.
Which ones?
Document databases, key value stores,
Okay.
graph databases, column family databases.
Yeah, there are a lot.
It's a bit overwhelming.
Don't worry, we'll break it down. Each one's designed for a specific purpose.
Okay, that makes sense. Let's start with document databases.
Okay, sure. They seem to be pretty popular.
Yeah, they came up a lot in those articles.
So in a document database, data's stored in these flexible containers.
So not like rows and columns.
Right, it's more free form.
More like a collection of things.
Yeah, like objects and arrays. They often use JSON.
Oh, okay, so you can store data that doesn't fit into a neat little box.
Exactly, like think of user profiles.
Right, not every user is going to have the same information.
Yeah, or product catalogs.
With lots of different features and descriptions.
Right, document databases are great for that.
There was an article I sent about personalized learning platforms.
Oh yeah, what kind of data are they storing?
Things like user learning paths and progress.
Oh, that's interesting.
They're using document databases for that.
Makes sense. Every learning path is unique.
Yeah. And a document database can capture all those differences.
You don't want to be limited by a rigid structure.
So how about querying the data?
That's the beauty of it. You can search based on the content of the documents.
So you don't need to know exactly where everything is.
Right. It's much simpler than those complex queries in a relational database.
That makes sense. Okay, now, what about those key value stores? They seem pretty basic.
They are, but powerful in their simplicity.
I'm not sure I get what they're good for, though.
Okay, so imagine a giant dictionary.
Okay, with words and definitions.
Yeah, but in this dictionary, you store data as pairs of keys and values.
So the key is like a label.
Exactly. And the value can be anything, a number, text, even a whole document.
Oh, so you can store a lot of information with just one key.
Yeah, and you can retrieve it really quickly using that key.
So they're good for things that need to be super fast.
Exactly, like caching frequently accessed data.
What's caching?
It's like keeping a copy of the data in a really easy-to-access place.
Makes sense.
Or they're great for managing user sessions and web applications.
So that's how websites remember who you are.
Right, so you don't have to log in every time you visit a new page.
I read that some online gaming platforms use them too,
Oh, yeah?
for tracking player stats and progress.
That makes sense. You need things to be fast and responsive in a game.
Yeah, you don't want any lag.
Key value stores are perfect for that kind of real-time action.
Wow, okay, so each NoSQL type has its own strengths?
It's all about choosing the right tool for the job.
Now those column family databases, those seem a bit more complex.
They are a bit more involved, but they're really good for scalability and performance.
Okay, so they can handle lots of data.
Tons of it, and they can do it quickly, even across multiple servers.
How do they do that?
So instead of rows and columns like a spreadsheet, you have columns grouped into families.
Oh, okay, so it's like categories within a spreadsheet.
Yeah, that's a good way to think about it. Imagine a giant library.
Okay, I'm picturing it.
Books are grouped by genre,
Okay,
and within each genre, you have different authors and titles.
right.
That makes it really efficient to find what you're looking for.
Like if you're looking for a specific sci-fi book.
Exactly, and it works the same way with data.
One of those articles mentioned financial institutions using them.
Oh, yeah. For what?
Tracking and analyzing market data in real time.
Yeah, that's a lot of data, and it changes constantly.
Right, so they need a database that can keep up.
Column family databases are perfect for time series data like that.
Time series.
Data that's collected over time.
Oh, okay.
Stock prices or sensor readings.
I get it. So you can track trends and stuff.
Exactly. See how things change over time, identify patterns.
Makes sense. Okay, last but not least, those graph databases.
Yes. The masters of relationships.
They seem to be getting pretty popular.
They are, especially for applications that involve lots of connections between data points.
It's all about the relationships.
Right, so in a graph database, data is represented as a network of nodes and edges.
Nodes and edges.
It's like a map.
Okay.
The nodes are the places, and the edges are the road connecting them.
Oh, okay, so the nodes are the things and the edges are the relationships.
You got it. So nodes could be people or products or events.
And the edges show how they're related.
Right. Well, who's friends with who